In order to pick within each pair which one has a higher boiling point, we need to start by classifying the molecule. So oftentimes that means looking at first, do we have metals only, nonmetals only, or a combination of the two. Magnesium's a metal, oxygen's a nonmetal, so this is ionic. Magnesium's a metal, chlorine's a nonmetal, so this is also ionic. That by itself didn't help us, but to compare two ionics, we're going to look at charge, and if charge doesn't help us, then we'll look at size. Magnesium is a +2, oxygen's a -2, chlorine's a -1. So because we have a difference here in the charge of our negative ion, that's going to be able to help us decide the answer. The bigger charges, regardless of sign, 2 is bigger than 1. The bigger charges is going to be a stronger force, harder to break, higher boiling point. Between these two, again, start by classifying the type of molecule. K is a metal, F is a nonmetal, so that's ionic. You might look at SiO2 and start looking at metal or nonmetal, but ideally you don't. And you remember that SiO2 is one of our 2 molecules that we always classify as network covalent. As soon as we have 2 different types here, we can just know which one is stronger. The stronger one has the higher boiling point. Network covalent is a stronger force than ionic. Between these two, nonmetal makes this covalent. Nonmetals only makes this covalent. In order to tell the difference between covalents, first I want to look at, well, are we dealing with polar or nonpolar? So drawing out the molecule and deciding if it's polar or not. This is going to be a lot more work than either of these two. So because they're all nonmetals, I need to draw the Lewis structure. CH4 ends up looking like this. F2, if you draw, looks like that. This is nonpolar. All the peripheral atoms are the same, and there are no lone pairs on the central atom. So this is molecular nonpolar. This, there is no central atom, but any atom sharing electrons with itself is going to share them equally, as opposed to unequally. That equal sharing also means it is nonpolar. So we did all of that, and we know they're both still molecular nonpolar, same type. What do we do from here? To compare 2 molecular nonpolars, look at molecular weight. It's a shortcut, but it works. The larger the molecular weight, the stronger the force, therefore the higher the boiling point. Molecular weight of CH4 is 12 plus 4, so 16. Molecular weight of fluorine is 19 times 2, so 38. Larger molecular weight, stronger force. CO2, nonmetals only, so that's going to be covalent of some kind. CH2Cl2, also all nonmetals, so also covalent. 2 covalents I need to draw. Then I can evaluate if they're polar or not. This one, peripheral atoms are the same, no lone pairs on the central atom, so this is molecular nonpolar. This one, the peripheral atoms are not the same, so this is polar. Therefore, just because now these are different types, molecular polar is stronger than nonpolar, so that will have the higher boiling point.